It is time. Hi, Legal Alien. Turns out getting 1,000,000 channel points takes longer than I thought. You have 150,000? I just don't believe that. I don't think even I would have 150,000 if I could earn them. Alright, what was I doing? I think I figured that I have to do a proper velocity iteration exchange between whatever the spring is interacting with. The only important reward is 9. Well, actually, no, there's another one. Highlight my message for 100. Yeah. Maybe I'll do some actual rewards eventually. Actually, now you got me curious. I want to go look at a channel that I've watched a bunch. I have almost 600,000 on another channel that I've been subscribed to for a long time, and I watch a ton. Forced to get reset hard? No. Also, doesn't it only delete what I've changed like that day? Hey Rodent, already upgrading? Yeah, I am. Show progress now. I can't because I have a problem. I mean, I guess I can. I don't even know what if you've seen anything different. I don't even know what I can show. Oh. Right. So I'm testing a spring interaction right now. I did fix the timescale not updating the tick rate. So now the tick rate is bound to the timescale, so I can still see what's happening correctly in slow motion. I have to fix the spring because right now, in a single... I'll even demonstrate it. Or demonstrate it. Of course I'm demonstrating it. I'll show specifically what happens. Oh, there's a breakpoint there already. Cool. I don't know why they didn't hit the other time then to like open it. All right, but in a single 1/100, by the way, I am at 100 ticks per second. So in 1/100th of a second, I don't know if you can see it. Okay, my camera covers it, but the linear velocity of this object, the ball that I'm landing on, is 1 meter per second. So it's bouncing up right now. It's bouncing up towards me. In a single instant, we go from 1 meter per second going up, away from the ground, to negative 195 meters per second into the ground. So that would be an I did the math, that would be an acceleration of just that times 100. So almost 2,000 meters per second of acceleration. Make it accelerate in the other direction and slower. Okay, so I've landed on it, which means there's been a collision. I apply the impulse to that of the landing, which this is the right calculation, I'm assuming. The calculation is correct. It's just that it's applying in such a short amount of time that there's no... I think it's more the spring force that causes this. And the issue is that the spring is calculating what should happen because I'm moving at like a meter per second, or like 2 meters per second. Actually, no. What am I moving at? I've been falling for almost a second. So I'm moving 7 meters per second into the ground. So it it just... the acceleration is just insane. So, basically my thing is that I'm just going to go into the spring and make the spring do a couple velocity exchanges so this result is better. And it's not accelerating it at such an incredible pace. When you assume you make an ass out of you and me. Well, I don't know how it could be wrong. The math is... in fact, it's pretty much copied directly from Jolt physics engine. Yeah, I know. Oh, hi, Yulia. I didn't even notice you and illegal aliens have the same color. Hi, Yulia. Yeah, I don't even have a bot. Actually, do I have a bot? No, I don't think I even have a bot. How do I see... how do I see the people in chat? Oh, there it is. Yeah, there's no... swagging with the badge. It's difficult to see. Okay. So right now, yeah, I think it, like, even just 5 is probably going to be good. It's also custom code, which I could at this point figure out how to, like, totally make this something. Wait a second. Could I have actually been using this the whole time? The thing is, I think this breaks. I think the way that joints work is they can technically break. They don't actually have the ability to reset. They only limit forces. Same color as the badge. Oh, nice. What is all that? Tylenol. Is this but it is between another rigid body, which I guess is fine. But I would like it to just have... there also, I mean, there is the general problem where the bottom of the character is technically, like, not there. Right? We're slopping in chat. What did I say? I don't even know what I said. What if... Well, no, it does have to be there. That's the joke. Okay. Can I even see it? What is that? Wait, which axis does it operate on? The x-axis. Why is this like that? Upper distance, lower distance? Lower distance, 0. Actually, I think... .7... How can I disable the spring? I could make the stiffness 0, and that would do nothing. Could do that. So basically, what are you sending? That's healthy. I think... So I've been going like every other day without any coffee, and then the last 2 times I streamed, I have had coffee, but I get like the smallest amount that I can get. And I think it's been helpful. I have also had a headache, like constantly. But right now I don't. Do you know what Blender's Z and Y axis flipped? Here's what I think. I think negative Z being forward is stupid. I think that's stupid. Positive Z should be forward. I mean, like that's the model front, right? Like I face down the positive Z axis and I see the front of the model, which is fine, but that should be the way that the camera looks by default. The camera should be looking in the same direction when I click here. Like I should see what the camera sees. Blender Z is up and down. Yeah. Upper distance. All right, I'm gonna copy this. 0.74. And then, or well, I guess what I would actually put in the same place that this is at. Is at 1.04. Yeah, but this is kind of the thing that sucks. But it also doesn't suck because then it means it's there. It's a real object. Imagine making sure every Blender Pi script runs with that in mind. I don't know. I think it's not like a big deal, but it sucks when you have to work with both of them at the same time and make sure you're converting correctly. That's when it really gets annoying. And also, I think it would be really obvious if you ever made a mistake too, because it would be visual. 0.3. And then 0 margin. Actually, I can literally copy it. Slider joint. How does this really work, though? What's ortho? Factor applied to movement across the axes orthogonal to the... Okay, that makes sense. What does angular even mean for a slider joint? Unless it's collision mesh, then you have to set up a visual debug. Oh, I guess. What does angular mean for... Okay, cool. So it's just straight up not even used. That's good. Alright, so I don't have to worry about that. Yeah, literally don't have to worry about that. What would that mean? What would it mean to rotate on a slider joint? Which way do you rotate? I guess it's that axis, so it's like clockwise looking down. And then orthogonal would just be any other rotation. So this is like when it's off, when it's moving away. Softness 1. Wait. Linear motion. Factor applied to movement across the slider. The lower, the slower the movement. That just doesn't sound right at all to me. Oh, cool, it's ignored. Alright, good. Don't have to worry about that. That's... Oh. Okay, right. This is a pure spring then. So this is totally limited. It will not pass. Let me check. I want to see what this is. Jolt, slider joint, slider constraint. What? Limits. Oh, there it is. Spring, frequency, and damping. Okay. What about restitution? Is that ignored? It's ignored. Awesome. Damping is ignored. No. Wait, what? I don't even get a spring? What? Limit spring frequency. How do I set those values then? Set jolt parameter. Jolt slider joint 3D. You streamed early today. Give me $1 million. You know what? Actually, now that I think about it, I should probably do that. I should look into actually making... Hey, that's just broken. Putting my bot on stream. What is it? Jolt slider joint? As like a break or something like that. Subnautica 2 got leaked? Slider joint set jolt parameter. Jolt physics server? What? What? Okay, I'm gonna assume that one's just like broken for some reason. Steam needs to get their crap together. This is bad news for pirates too, because now they're getting more attention. This is bad news for pirates. Jolt physics server? Is this like a switch I gotta turn on in the project or something? Why is it not there? Tired of Steam piracy as far as I know, relies on one DRM script for Steam from a guy who doesn't maintain it anymore. Well, I mean, if it works, you don't have to update it. Oh yeah, this was a good video. Jolt physics server. Why does it even autofill? GDScript native class. It's there. It's literally there. I could access it. There's just no... Slider set jolt param. Slider joint set jolt param. Yeah, this is weird. Why? Why is it even there? Jolt Physics Server 3D. It's not even a bind. Jolt Joint 3D? Slider joint param jolt. The thing is, softness and... I guess it's not really softness. Softness has a weird value too. The lower, the slower it is, which means it's... Okay, well, fortunately I can't actually use it right now. So that's good. I'm fine with that. So I still gotta go with the iteration thing. Okay. So let me just go through this because I think... Jolt slider joint creates a slider constraint. Okay, just slider constraint settings should lead me straight to the file. Axis constraint part, position limits constraint part, position constraint part. What? Okay, this is slider constraint. Looking for solve, velocity and position. Solve velocity, motor off. Oh, there is no motor. Position, rotation, position limits. So I know that axis constraint part is just like a super pure spring. You give the axis and it will spring along that direction. Position. I don't know what that is. This one should just be applying it. Okay. That's a dual axis. Oh no, those are two axis yeah, the position limits constraint is just the spring. Which... Okay, wait, let me see how that's set up. Okay, so it lets it move freely, and then it says, I'm guessing once we're outside of the range, it uses these values, so then it's like actually a spring. Okay. Okay, so it is just purely a spring. So I'll just go to axis constraint part. I guess it's that one. I mean, I don't know how it is, so... Okay. There is like this lambda thing where it accumulates it, and then which is just the actually just the force. But lambda is... Honestly, this is like such messy code. It really is. I dislike it so much. It is like 90% template, and then like 2% actual logic. Yeah, okay. So it's just recomputing it every time. But it's summing it up too. So I have like some amount of force for like a substep, and then I'll say, all right, this is how much force should be applied for this amount of time, and then I move them around, and then I check what the spring says now, and then I do the opposite, which in a single instant, you know, like in an instantaneous impact, you know, in the real world could be like 200 meters a second of acceleration, but then now the spring damping is keeping it from extending that significantly, and the object will sort of pull on it a little bit. I don't know. That doesn't make any sense. Smaller steps would be more realistic. So at least no matter what, splitting it is going to be better. Okay. I should probably multiply the total force by the step, right? Because it is meant to be applied over that amount of time. I just have to recalculate the bias every time. Let's see where total force is used. Plus total force. That's the debug. Okay, no. For what force is supposed to be, it does not make sense to multiply by step. But when I do iteration, I will be summing it at that point. So I should just call this solve. Solve forces between two things. Iteratively update velocities and positions for rotating results. Reset the states after calculations. Okay. So I will be doing the impulses could be applying angular velocities. So I will say I have to save okay, well, I'm going to call it solve, which means I'm going to apply it right away, which I think is best. I should apply the forces immediately, so I actually can just apply them continuously, which that is what it's doing. It is applying them continuously. Wait, what do they do? They solve and then they apply. Which, I mean, I guess in that case it makes sense, because you might do two solutions and then save, or then apply to positions. Right? But in this case, I'm just going to do both at the same time. I'll do a position and a velocity update every time in sub-steps. So I need iterations constant. I will not be resetting the states. I'll be applying them right there. Yep, I have to apply them in there. And then I need a sub-step value. So just be how much of a total force I'm applying, which would just be... I can actually make it a constant too. It might not like it because I use float there. No, it's totally fine. Okay. I can close up the stuff. spring, linear velocity. This cuts out. Actually, okay, so here's kind of an issue. This is probably used. Right. This is used up here, but it also already applies to my velocity, which I will have been moved by this. I won't be rotated, so that actually doesn't do anything there. I won't be rotated. This has me move. I don't know. I save everything right away. I apply damping immediately. Calculate ground force. This applies ground forces to me. This applies ground forces to me immediately. If stop friction is not 0, wait a second. Because I'll be calculating it there. This is my current relative ground velocity. I discount whatever spring and gravity has applied. Would apply, because I haven't actually applied them yet. This would actually just go away. This would just go away. Because now gravity and spring force is already included in my velocity. Because here what I'm doing is I'm saying, okay, well, discount those from my force because I need to discount those because gravity will handle this much, spring will handle this much. And also, stop friction just sucks right now, too. This has actually, like, continuously been a problem that I get to. I'm like, oh, stop friction is, like, something crazy right now. This has always been a problem. But if I were to apply gravity immediately, I apply the friction right here, then I apply gravity and like slipping to push me away from the wall. Then I apply the spring. Then this is where actually, yeah. So these are like friction, gravity, these are all forces applying to the body prior to motion. And then motion can do things against these values. So I think what I should do right away is make it so that these are applying immediately. Really. Reduce air friction up to forward movement amount. I suppose I can account for air friction? Well, not really. No, I think it's actually fine, because if air's like has decelerated me, then I get to the movement step and I say, oh, I can accelerate by some amount now. It will already be disregarding it. It's already going to disregard it. Same thing with ground friction. If I have some friction pushing me back, I will look at that and say, I'll have the velocity updated and then look at what I can move forward and say, oh, I can move forward. I can accelerate. So it's already going to discount this stuff. So yeah, I should be applying them as I get to them. I can get gravity, I can get air friction, I can get ground friction. I calculate these forces that are going to apply to me in my current state, and then I apply them all at once. That's what I should do. I do damping right away, but then I should apply them all at once and then see what I can move on top of that. Which means I would have to... I should be able to take this stuff out. Because when I'm turned this way, then that ground friction's applying to me that way. So I don't have to do this. All right. So because... Or I actually delete. This is my idea that I can just start applying... Not apply them, but I calculate all the forces that are going to act in the body. Then I apply them, and then I do movement on top of that. After everything is settled. Without character controller. Because that's just spring changes. All right, I can go for it. I think this means I can go for it. Stop friction is meant to be... Yeah, this should probably stay here. But I don't need this stuff. So this is more of a movement force as well. Which means I have to have already applied this stuff prior to that. But this one's fine. If stop friction is not approximately 0, then I think I just apply it right here. Ground friction is applied like so. Okay. I could probably just change this to be like as if I was pressing back or using deceleration, but like in that direction. So I would set a forward and then a speed, which is probably exactly what I should do. I should just set the forward and then the speed, because then it will apply down here. Limit in direction. No, I think that's fine. Jumping reads relative contact velocity. But it does not read my current velocities. At least not from state, so that's fine. I have to add the jump. I can't remember exactly what jump is doing here, but I think there's something where it could just stay 0 until I get to it. But I guess I can just do it here. Is jump used anywhere else? Does not seem like it. So I calculate gravity, I calculate air friction, I calculate ground forces, which will also I mean, the thing is, I can apply them as I go, which I kind of would like to do that. I think I would like to apply them as I go. So I probably just need to rename this to be solve ground forces. I guess maybe it's also because friction is here too. Maybe I should just take friction out. Or not even do the spring in here. But if spring and spring is colliding, I guess it is just purely from there. Yeah, I'll call it solve because it will solve it. And it'll do all the motions of the spring and then apply. Actually, what should it do? I think it should take gravity, apply gravity, air friction, apply air friction. And then iterate on the spring, applying all the velocities. And then it will calculate ground friction and then apply ground friction. So before I get in here, I think I need to apply... Yeah, I think before I get in there, I have to apply gravity and air friction. All right, so I'll just do that. Add a slip force by projecting gravity along the downhill vector. Okay, so this is how I apply it. Oh. I think, okay, so I think like the ideal correct thing to do would be to apply the acceleration from gravity so spring can work with that. But because I do this where I actually need a ground collision, actually I only need a ground and normal. Okay, so I guess what I would do is I'll split this up and I'll say, get the ground information, like the ground normal, and then I do that. So I'll do 2 steps here. I'll do update ground where I don't even need to have state. So I just move this code up here. And then otherwise, turn off slipping, turn off basically everything. And then if is on floor is true, well, here I just return. But then here I say spring save state. Spring save state. If we're not colliding, yeah, we do that. Okay. Otherwise, I save it there, which will get the collision normal. Don't really need length. Because yeah, this will just, more or less, this will just be a reliance on the damping to account for any of that. But also I would kind of like to, when I update the positions, to redetermine this. But I don't think I can do that because it will tell me that it's iterating and I can't do that inside of integrate forces. Yeah, I can't do that. I have to rely on the spring to have already been updated. Yeah, because I don't... Oh no, I can. I can do a force shape cast update. I can totally check stuff while I'm doing it. Okay. If I can check it while I'm inside of this step. All right, that's fine. Okay. Yes, I think I can still just use is colliding, because what I'll be doing is I'll be virtually updating stuff, which I say virtually updating it. It should be literally updating it. If I move an object using the state, that should be directly affecting it. So if there's a case where something rotates and it changes the collision point, then that will happen. Okay. So save state's right. Save state's correct. So yeah, just move this up here. Which means, now that I think about it, could I not just use save state every time? Also, this is wrong because... Oh no, is on floor wouldn't have even become true in the first place. Okay, let me do this. If we have a spring... Trying this. If spring is colliding, and we're only checking it if we're not on the floor. So if we're not on the floor, so while it's false, we'd be trying to set it to true like that. Oh, no. Kept rewriting it, but yeah. True, and then otherwise, I have to reset. Which I think is just... Yeah, it's more like this stuff I'm trying to make sure is... Okay, you know what? Let me try this. I think this is the way to go. If we are on the floor, we have to check spring stuff. If we have a spring, save state. I can also just compare the length to infinity. So this is a reset. Ah, gosh, this is... I hate this. I actually don't know how to figure this one out. I want to have it so all this reset code is in one spot, but then somehow order all the checks in a way that I'm calling the spring when it's valid, and if it's not valid or it's not colliding and I don't have a floor, and I did have a floor that I'm resetting. are not on the floor. We're not on the floor, and we are now. Set those on the floor to true. Otherwise, if we are on the floor, reset state equals true. Okay. Now this check can just say if reset state is turned on, this is all that we're doing. And I have this check. Whoops. Didn't even really change anything, so that's fine. Because I already called save on it. I'm just resetting the total force there. Which I don't even know if that is, I don't even know if that's necessary. Because it should. Yeah, this does already reset every time. So I actually should just leave that out. If I reset the state, everything becomes 0. This stuff actually doesn't happen here. This actually doesn't happen here. That is calculated later. So I'll move this down here. Is slipping. This is just an update, so I don't really care. I'm just updating it here. And otherwise, update ground will then run through all of this stuff because then we need to know. Hit position should only be used for impulse application or reading. So yeah, I don't use hit position. But I run these checks. I don't think I use ground mode there. I guess I actually don't use that either. One moves up here. This moves up here. I need a state, I guess. And then this is like preparing a better collision here. Okay, so I do want ground. I do want that. And this is force calculation. Okay. So really just need to copy this line up here. And I can move this line up here. Okay, does this make sense? So I try to find the best ground I collide with. Slipping is false. If this is a bad angle, slipping is true. Well, technically this, because I'll be doing position updates, and I assume that means they really do update. So when I do queries for intersections on that, the spring is actually updating there. So slipping would actually be calculated later. Yeah, but my interactions will be fully on a single body. Also, right. When I'm doing the position updates, they do have to be virtual because I have to reset them back and then use the real, or use my final calculated velocities, or my velocities will be just as they are. The reason for that is because then the server is going to go through, read my velocities that I've applied, and reapply a position change. So it'll like do it twice, which is not what I want to do. Well, actually, maybe that is what I want to do then. No, because I'll be... Actually, right. Yeah, no, that is right. I think I'm only checking what would be happening if nothing was actually moving in the first place. So I'm doing my iteration. I am still applying the position changes, and I'm still accumulating velocity, but when I calculate the changes, I'm calculating it based on what my iteration step has just applied. Without specifically excluding whatever its incoming velocity. Actually, no, that's not right. Okay, no, I'm right. I have to reset it. I have to reset its position, but the velocity will be there. But I will have to reset the positions. The reason I'm saying that is because my thought was, when I go through the update ground, technically that would change this ground normal, and that would change slipping. But it won't, because I'll reset the positions, so whatever I saved here for slipping and the ground normal will be the exact same value after I reset the positions. I guess part of my thought was, do I need to move this code inside of the iteration step? But no, I shouldn't have to. The spring iteration will purely be just getting a better velocity result. Because basically what happens is I do a sub-step. If I have 5 sub-steps, that like 2,000 meter per second acceleration becomes a 500 meter per second acceleration. But then that will apply to a 500th of a second. So it'll move a very small amount, it'll accelerate only 500 meters per second. that will change the length of the spring, so the spring stiffness will, the spring will lengthen slightly. It should lengthen slightly. But then because of that velocity change, the damping is going to be like, oh wow, we gotta like go the other way now, really aggressively. So it'll be a lot better interaction there. Because in that negative 500 to 500 meters per second acceleration would probably become like maybe a positive 100 at that point, and the damping will go like, okay, so negative 500 to positive 100 to like negative 50 and then positive 20, something like that. Like that's what would happen. I mean, maybe, probably not bouncing like that exactly. I think overall it would still be a down push. It'll just be whatever the result should be, it'll like bounce around that and get really close very quickly. This would then be spring solve forces. And it would just take in. It's slipping. What is slipping? Is slipping for override collision. Which means we don't apply the spring when we're slipping. Which I guess is fine. I mean, honestly, in that case, what I should do is I should just check at this point. After I run through all this, actually not after I run through all this, because this stuff will be moving. So yeah. So I can calculate this stuff just in preparation. The hit positions will stay the same. So I can just kind of pull that whenever I want. Actually, maybe not. Okay, I'm going to say I need to save that. I need to save the ground position. Okay. And it's probably possible that I do not. Okay, good. And I have to update this here. So I do a second cast, ignoring that one, seeing if it's better. And then I guess I have to save state because I've changed it. But shouldn't I save it up here? Yeah, because this is the one that I'm using. But then ground RID, what? I only want to use it if it was better. Could that have been a bug this whole time? It probably has been a bug that I've been doing that. It definitely should be a bug. Because I'd have an incorrect ground normal that could be like, oh, like say I'm standing on a surface that's kind of bad, and then right beneath it is a surface that's even worse. I would end up with the worse ground normal, and maybe I would like slide faster off a surface than I should be. Is kind of like what I think would happen there. Let me flip this around too. If this is true, set that, return. If it is not static, we're done. This is so much nicer. Object is a static body. Ignore this contact and recast for better static body surface. Proves interactions near steep walls. So I save that to a temporary, add an exception, force an update, remove the exception. So the next normal update will get it. If the spring is colliding. And the mode is static. I don't really want to duplicate that line, so I'll just leave it like this. The same exact line down here. If it's good, we save it. We update everything. No more slip. Wall, slide, and normal. Only used when is slipping is true. So wall, slide, normal. I'll do this. I'll reset it. Okay. That looks nicer. So I will do update ground up here. I can kind of just run it right away. Okay. Right, this is an air friction thing. Like really what it should be is there should be like some kind of shadow calculation. I don't do that right now. I'll do that later. Because I'm already doing a bit of a refactor right now. So this would just be ground detection. Just be update ground. Which, I mean, I guess I can run this as early as I want. Because it doesn't really matter when. Okay, so I think what I want to do though is actually use that to redirect, right, okay. This, I forgot why I did that. So the reason I needed to do that was because that's for direction here for gravity. I'm redirecting it like this. So what I want to do is actually just kind of move this up here before I even do gravity. So then I can actually do this. Add a slip forced by projecting gravity along the downhill vector. So if gravity is not 0, I check this, and then what I really mean to say here is that gravity just becomes this. Which, I mean, is kind of bad, but when slipping, reproject gravity along the downhill vector. This also requires that I have ground, but slipping should only be true if I have ground. Cross product returns 0 when they... If the two vectors are parallel, this returns an empty vector. Okay, so I start with this. Can't I just do downhill? No, I need a direction. Because dot returns a value. Okay. I guess I can get the length at this point. No. I kind of have to keep running it like this, don't I? I mean, I think I can do it with the... I think a cross with a 0 is actually fine. Let me look at what that is, because I don't remember. It's not there, it's in math. It's probably the header file. But can I spot it? So if one of these vectors is 0, it becomes 0 minus 0 every time. Okay. Okay. Okay, so I don't need to do that check there. I can just run this in that order. And then if we're not 0, normalize it, reproject. Okay. Linear velocity. Lateral speed plus vertical speed. Which is just a way of saying linear speed. Okay. Apply damping forces immediately. Pre-compute this for forces, I guess. The thing that sucks is that this is going to be inaccurate because gravity, air resistance, motion will all apply unless I recalculate it at the end, which I don't, so they're actually kind of useless values. And I also have to recalculate it after I do forces anyway, so... Huh. One second. That is a bit annoying. Because I use this for acceleration, which is what I've said is important because after I apply gravity, after I apply air resistance, after I apply ground friction, then I can use my acceleration to move up to my desired speed, right? And then that will have applied ground velocity. If I did a rotation, that'll apply it directly against where I was going, so that's going to transfer my velocity very quickly. To where I'm facing now versus where I was. Yeah. And I think I want to apply this before I do the spring, because then the spring will determine what my friction should be. So now I do this. Solve ground force state, which will update the state. And then right. So what I do here is I then say state actually, I think I just do gravity first. I let the spring update. Yeah, I think I just do gravity. So I I'll move this up here like this. Update ground. I apply velocity. Times step. And then I guess it's fine to do down here before I do solve. I guess all nodes. I do the special stuff for there. Where's gravity applied? Gravity was applied. Right, okay, so this is important. I have to make sure I do this right. Custom pre-movement forces. What does this do exactly? This takes in my current velocities at points. Computes the rotations that would be applied. And then corrects for those. Specifically relating to gravity. But then I think this is applied. Gravity has already been applied at that point, hopefully. If gravity has been applied prior to doing that, you have to save it. Spring is applied. Gravity is applied here, spring is applied. And then custom pre-movement forces, which comes in here. Okay, so good for me. I'm applying basically all forces but movement. Yeah. Any forces before movement is applied here. But this is also after all other forces have been applied. So it's literally between non-movement forces and movement forces. Okay, good. So this should continue to work. Because that's where it's done. But I don't have to apply spring here because I apply it outside of that. Does this reset total lambda? Right, so the way this works is that it does accumulate it and maintain it over time. Which means technically this would cause an inconsistency if I were to add a, like, when I do add a save feature. Which means if you're saving and the spring has some small force or some large force, it might come back and have like a single tick of like really poor accuracy. If it was applying a lot of force, then you might, like, if you're saving and coming back every single tick, it would, you might just like fall continuously. Even though the spring should be like building up some force, or it might do like one where you fall a bit more, and then suddenly on one tick you have like an insanely high force because it should have been building up and correcting itself, but suddenly it comes in here, the iterations weren't enough, and you like go flying into space or something, like instantly, because of a ridiculously high build-up. Or just the other way around. It could be that it was applying a big negative force to keep you stuck to the ground, and then you reload it, and then the velocity is still high, but the build-up from the previous frame isn't there anymore, and now it like sucks you into the ground or rebounds you in the same kind of way. Those are like extreme cases, I'm sure. But is the case that what they do here is they are saving it and they're using this bias function, which I would assume is like the damping. This is the damping part. Or maybe not. What is it? JV is the relative velocity on this axis minus spring part bias, which softness times total lambda, which I think yeah, this is just a bunch of, I don't know, some like really just like a good spring simulation, I guess. But I mean, I don't really have to follow that exactly. And I think I tried before, and I said this just sucks. So maybe I don't really follow that exactly. Yeah, that'd probably be better. I'll just recalculate every frame. I don't have any build up. Well, I start at 0 and I build up from there. Every frame. I don't maintain a running tally, which is what that one does. Physics step to physics step, it maintains whatever's happening. This is debug. Which I guess is right. That's a good place for it. I applied jump here, which maybe jump should go further back. This doesn't change is on floor. Yes, doesn't change is on floor. Okay. Should this then happen? Because this is technically a movement, right? Yeah. I'm going to change it. Technically that is a movement. But even more than that, it actually should go before I even calculate movement. Yeah, this should go way up here. So that movement is still relative to after whatever the body has done for accelerations, force accelerations. Look over here, so that springs should it also be friction actually, because that is kind of an issue. No, because the springs will handle their relative velocities. They should handle them well, and then yeah. Solve ground forces. There's just solve ground force, which will compute a friction based on the result of that. It should also apply the friction as well, I think. I guess I could also apply air friction. No, I'll just do this down here. And I could do friction there as well. So let me go see. Yeah, get this up here. Friction would be air friction plus those two together. Okay. I wonder if I should actually do this here instead. Just apply it like that. So I'm not actually updating gravity, I'm just applying it in this different way. Mm. Should I play it like this? Yeah, it needs to be a slip, right? It has to be a slip. Should it just be an extra force instead? So I already apply gravity that way. I'll do that. But this should just be an extra force exclusive of gravity as well. So it should be, when downhill is aligned with gravity, it should actually be 0. And then as downhill is not aligned with gravity, there's the extra force pushing you off the side. So I could look at it as I guess I could look at it as actually this dot would actually be like it'd be like the 1 minus the dot, right? No. It should be like a reprojection. A full reprojection. I just don't want to write it twice. But I want to keep gravity as that thing pointing down. Yeah, because what this means is that if... basically becomes like a frictionless surface without applying any gravity in the first place. I still want to apply gravity, but then... yeah, I still want to apply gravity. Then downhill has to be not really written like this. So I'm going to visualize it. I want downhill to just be like a force that's perpendicular to gravity instead. So the gravity will push whichever way it goes, and then the downhill will push some amount orthogonal to it. What exactly does cross produce? A vector perpendicular to this and with. Could I just do this? Then minus downhill's projection back on a gravity again? So like downhill times downhill, which is projecting gravity onto downhill. And then I subtract that vector's projection onto gravity. Does it not want me to use gravity there? Okay. when slipping. Extra force orthogonal to gravity in the downhill direction. This is also technically called slide along a normal vector, which I just want to make sure that is exactly what I wrote here. This minus the normal times the dot with the normal. Exactly the same thing. Okay. But then I think I do this probably here instead, because I still apply full gravity there, so then springs act on that, and then springs are not then subjected to this slip or air friction or ground friction or anything. This will apply ground friction. It'll apply ground friction based on the current velocity into the ground. Which the spring will end up pushing back on it some amount. Should friction be computed immediately? It probably should be computed immediately there. Yeah, okay. Okay. This is our forward ground movement. If we are slipping, we do a bunch of that stuff. Ground velocity is calculated in ground forces. This kind of has to be checked. Yeah, these all kind of have to be checked. I don't use it there, so I can actually compute both these right away. I'm slipping I do both of those, and I think that's kind of it right there. Which forward is now set to that, so I can just use forward here. Just write that. I guess I can actually rewrite this just be forward. Because it would be nice to cut out 2 crosses if this happens to be 0 still. I'll just do this. And let it nest horribly. I hate it so much. Should I just make that a function? Because there's a lot of times that I just would want to return. I'll leave it. But I'll leave a comment too. There's a bird looking at me, running across the yard. Limit forward acceleration, incline effect. So on an incline, I'm doing stuff. Limit in direction is desired speed. Yeah. Speed in direction is linear speed, but this needs to be recalculated. Alright, this will be a function. Update motion. I'll just do this right above ground. Cool. And yeah, I'll just call it here. Whoops. Might be nice and update motion there. And then I update motion again. And then finally, at the end, before I return, I update motion once more. I mean, I guess at this point, it's probably not even used anymore. So it's probably fine to just exclude, but linear speed is right there, so I actually do use it for debug. Then I have to. One final time. Which, that does really suck, because there's like the length stuff. But I mean, it's all really simple math. The only thing that's complicated is the lengths. You know what? I wonder if vertical velocity... You know what? Are these even used? Okay, they're public value, so... Tough. Okay, whatever. I just leave it. It's a lot of updates. But I think it's fine. Because those, like... Math is fine. The math is fine. It becomes a problem when I'm doing, like, iterations and using loops. Matrix. Transform math. Which I guess is this, but yeah... If this becomes a problem, I can always just write it and see. Right. Update motion. Because it's used here. You know what? I'll do it up here. Do I damp before after gravity? I guess I should do that before gravity. Background update motion. Leave a note. You know what? Maybe I bring this after that. Which means I only have to do update motion. I can kind of combine it. I guess not really combine it. Air friction needs the value, but air friction updates that, which this one needs the motion update, so I have to have it anyway. That's probably just cause mine error. Motion update ground. Yeah, because friction debug vec is used up there. Friction movement debug vec. If debug enabled friction, okay, that's fine because I know that that's there and I might bring it back. Okay. I'm gonna move this up here. This is after spring has been computed and air friction. And then yeah, now it's just kind of clear what's going on. I just want to be super clear why all this stuff is happening. is on floor, speed and direction is ground velocity. Speed and direction is ground velocity dot forward. Ground velocity dot forward. Okay. What is this? Okay, I need forward before I can calculate jump. And there's something happening here where my velocity has updated, which means I think I'm actually getting a boost if I do that when I jump, which is actually fine. A boost there makes sense. Yeah, because then I apply an update to my velocity, which is actually going to have some forward component. Or it's just going to have some forward component. And then I will accelerate on top of that. But I recalculate it here. If I'm on the floor, I do that. If I'm not on the floor, I use whatever my ground velocity was calculated to be. Should be updated using new velocity. Is speed and direction used here? It's not. Okay, bring it back in here. This has to happen before I jump, though, for sure. This is to zero it due to any free movement forces. Okay. So I just realized this should be... This is actually a center point. I know these two are different values, but I'm okay with that. Am I okay with that? I'll just move it down slightly. So wait, what? Oh. There we go. Okay. So that's just times 0.5. And this will move up 5. The motion is on floor. That's all good. Stop friction. Right, I cut some gravity spring stuff out of that, so that's already fine because it's already using computed ground speeds. Yeah, this ground relative contact velocity, which will be after solve ground forces. I mean, okay, so air friction always acts against my direction of motion. One half times density times negative linear direction. Yeah. Always acting against me. Should I play air friction up here? I guess if I know it, I should apply it, right? So that springs are acting with that accounted for. But I don't know. I don't even know why I would do that, because I can just do times state step. Right. Vertical stopping opponent with spring correction. It's not really true. Causing weird interactions on slopes. Relative ground. Y times Y ground velocity plus ground relative contact velocity slide. I guess I'd call it a spring correction. I guess that's kind of correct. It's not really correct. Let me to do this. Yeah, you know what? The more I look at it, the more this one looks like it's totally dumb, because ground velocity is ground relative contact velocity. Ground velocity spotted along the plane of the ground. It's weird. I don't know. I'll leave it. But it feels weird now, looking at it. Okay, what's the problems now? So if I was slipping, I would just not apply the spring force, but I still want to do that. I actually definitely still want to do that. Because of what happened here. If slipping is true, I would not apply the spring force, but I definitely want to do that. Because I'm still going into the ground, so the spring is still pushing me off the ground, but then I'm adding an extra lateral or an orthogonal to gravity bit to push me away from the ground, or to push, like, help me go downhill. And this should be acting on all of that. Yeah, it's acting on all of that. It's not acting on the slip. Maybe it should act on the slip. Alright, we're back. Taking the dog out. Hello. I'm feeling pretty hungry. And I'm gonna risk it. I'm gonna get food early. So I'll be back. I'm back. I've got food. I'm going to eat. Um, okay. I actually just had a realization. So one thing that let me hide some of this stuff. Joint. So the IK for the legs is actually on this bone. Here, 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 and here. So it's 4 joints. And joints by default have this option to exclude nodes from collision, which just means the 2 nodes that are jointed together won't collide with each other. Which, technically right now, this one is connected to the main body, but it would actually be connected to this joint, then this joint would be connected to the main body. Which is a problem because this one is already intersecting the main body. So by default, it would be colliding with the main body. But the way that it runs that is actually just goes into physics server and calls exclude or add exclusion RID. That's all I'd have to do. I could just go into each one, check to see if the bodies are already colliding with each other, or I guess the shapes are already colliding with each other, and then just add an exclusion if that's true. So I don't have to come up with a more complicated shape for the body, collider for the body. I just leave the same collider. I just check to see if any shapes, with the assumption, I don't know about like shapes, or I guess it would be like shape, collision, shape sections is the query that I would perform. So I could just query to see if any of these shapes intersect with the main body shape, and if they do, make that body not collide with the main body. Because technically I would want this one and this one to not interact with this main collider at all. But this leg and this piece and this piece should interact with the main body. If they ever get put in such a position where they could in the first place, which they generally won't. But if it's possible, then they should collide. But this one and this one should basically be, especially the inner one, because it could only rotate such that it would like be inside of, like inset to the body, so the motor's like pretty protected. And this one would pretty much be the same thing. It would have like space around it so it could pivot however it needs to, so it shouldn't interact with the main body. But then these two things wouldn't be included in that, because this joint is still inside of the body. Right? My fake collider and mesh have this joint already still being inset to the body. So this would be like some kind of port, like a slider that goes back and forth, and like some, you know, rubber covers or something, so that when this goes up and down, it can freely do so without hitting, but it would still be like sealed. So it'd be kind of like that. If I ever get that detailed with the body, which I might not. I might just kind of keep the shape like this, where they're just rigid blocks. Very simple meshes. Yeah, I just want to say that out loud so that I would remember it better. That is what I should do. I should check any shapes to see if they collide with the main body, and if they do, add that as a permanent exception. In the exact same way that the joints do already. Alright, I'll be back. I'm back. Okay. If I start getting tired, I'm gonna stand up. But for now, I want to sit down. Okay. I'm just gonna close that because I don't want to save anything. Why am I staring directly at the sun? I think I probably just close all this. I don't need any of that open. Okay, so if I think about it this way, this will negate any forces of gravity, giving me some distance off the ground. And then if I'm slipping, this will push me away from the wall. What this means is that the spring is not pushing too hard. So I could fix that by just not applying. I mean, this is what I was doing. I wasn't doing that anyway. I'll just say that. Remove the early application of problems appear. You know, I'm actually going to say it is wrong. I'm actually going to say it's wrong to do that. And if this is being weird, then I'll do the same thing. I'll change it back to how it was. Where I'm just totally shifting the direction of gravity, effectively. It's hitting me. My feet's kind of hurt right now. I really want to stand. Oh, sitting is so nice. I'm gonna keep sitting. I'm gonna try it. If I seriously just can't, then I will stand. I gotta break this. Whatever my body and mind think should be happening right now. It's like the entirety of noon. Like 11 to 3 or something is nap time, apparently. Let's debug. The motion pre-movement forces. Low speeds, I'll zero anything. I actually want to do the same thing for angular. Angular might be somewhere down here. If target is 0, desired rotation has desired rotation. Is it true if we want to do y'all? I want to change it more than 0.5 degrees. (8.7e -3), 8e -5. And 5. What did I do wrong there? Why would those be different values? They shouldn't be, right? I mean, I guess I just shouldn't. No, this makes sense because... Yeah, no, I understand now. If I was like times 2, it would be the same either way. But since I'm squaring it, I need to convert degrees into radians and then square that. And then compare it to that. Because I have radians to radians. So I should probably say 7.6. Should I say 7.7? Six two. How am I hitting 7 every time? 7.62. Let's see that. Let's go to the... Yeah, 8.7. Okay. So that should actually be a fix for something old. Where I would basically never be able to get the rotate to face me until I tried several times in a row, and then I would do it. Target angular 0. This actually doesn't do anything. It actually doesn't do anything. Never mind. That's dumb. Yeah, I guess I still don't understand why that happens. Our target angular is 0. Our angular velocity is 0. Then clear things. If we want to do some rotation, we have desired rotation. In fact, this should really just be if angular is positive. Yeah, it's going to be mean and just totally ignore everything that I'm trying to write in here. It does not want me to have autofill right now. This might be the mistake. If we want to move if our offset is more than half a degree, we still have desired rotation. So if our angular is greater than this value, I'm assuming what the issue is that target angular could actually end up being zero, and our overall angular velocity is also really low because we've already reached what we want to go to, but our angular is still really high, right? That's my guess. So I want to clear this until I'm near 0. And I definitely don't want to turn to something. Because I guess what happens is I get in here and these two values are already nearly 0. So it ends up clearing it for some reason, even though this is some positive value still. So that's why I would like click and it would like do very small rotations and just instantly forget. So maybe that's the fix. Okay. I'm gonna do the same thing again here. I just clear them if they're really low. But this one won't zero its velocity. It'll rely on the other thing to zero it. Has this rotation is used for by the legs, I think. I think I'll actually move this one up here. Do not have our desired rotation. And our target 0, and we're approximately 0. Lowering velocity facing target, clear target. In fact, I think I'd probably just get rid of target angular. We're facing the right way. Yeah, alright, so now that it's 2. Low angular velocity and facing the target, clear target. There's no other returns up here. What's that to do? Damp rotation as if by air friction. Not necessary. Also, there's a problem right now where air friction doesn't apply to rotation, and it should. Though I have no idea. And there's something with it. There's also something with angular velocity anyway, that it has a tendency to like create a shield around itself, or air friction, especially with rotations. So it kind of falls off much slower than if it were just pressing straight into air. But with the rotation, you can kind of like take... I don't even know if that is even correct, actually. Forget it, whatever. Okay, this might be fixed. The weird stuff there, where it would just never rotate. I'll find out later. Okay. Less than half a degree per second. Okay, and this all applies. I think it's all right. And now we're just looking at solve ground force. Which I don't care if I'm slipping. I'm going to do it anyway. Yeah, I'm going to do it anyway if I'm slipping. I guess that's the only one. So now it's onto solve forces, which will take the two bodies. And that's it. That's all it needs. It needs a bias. It needs the bias. And then otherwise it can compute everything. Yes, this will just go away. Takes in state. It will deal with other state just not existing. Actually, no, it won't deal with it not existing. It needs to exist, but it will deal with it being a static body. So if it's a static, then it's just not going to apply. I mean, it can. Because I think if I run apply impulses on a static... Actually, no. If I run that on the static, it'll still do everything, but... like, the background code just won't... It'll just kind of ignore those velocities in general. And then, not update the position. And just clear the values. Or maybe not even clear the values, just leave them and just ignore them completely. Or setting them just as nothing. I don't know. I actually have no idea now, because that would change how friction works. So if I had a static body... Wait. Hang on. Moving surfaces. Okay. So it says by using constant. Which, yeah, I'm assuming this just sets the value. Yeah. Or it would impart that onto things that collide with it, as if by a collision response, which is just friction and collision response. So yeah, right. So I can still give it velocity. I should just not do that if it's a static body. And then that's all I give it. And then I just totally ignore slipping. If I hit save, it should be fine. If I hit save, it should be fine. Yeah. And then I guess I can probably... Right, okay, so this is actually all gonna calculate in there. Ground state will be left with these values. I have ground contact velocity, which comes from all this. This should be up here. And then I read it, and then I compute friction and all that from this point. But I can kind of just take that out because I know what this should be. Is there an early return? Wait, solve? Okay, hang on. Update ground, solve ground. Update handles spring not existing. It handles a minimal reset, which is the normal in the position. Solve needs to handle all that too. So solve can just set everything to 0. And then if I can just return right there. If that's false, then I can't do anything. And I'll just put this down here. Let me make this a bit simpler for myself. Because this happens in spring solve forces. Using the relative contact velocity. And then I'll kind of copy this over. I guess I'm just kind of working backwards. Right, this applies at the end. Or I'm summing. No, yeah, I'm using the apply impulse to get it to update the velocity, and then I virtually update the position, but I'll remember the positions and then reset them back at the end. Technically, I do still have to compute friction from the ground velocity as well. So still have to get this, but it's more just that I won't be translating it if the mode is static. Or I guess I only care if the mode is... What are the options? Okay, so I guess what I'm actually looking for then is for static bodies, I don't update the velocity or the position, but I read the velocity. For kinematic, probably I probably update the velocity and the position. For rigid, I do the same thing. No, for rigid, I update the velocity, the position, and the rotation. Rigid linear, I treat rigid linear like kinematic. So I guess what I can do is I can just do a switch that's like apply position, apply rotation. Static would have 0, kinematic would have position, rigid would have position and rotation, and rigid linear would just have position. Okay. Okay, so I think that's what I do. Only its linear velocity is affected by... Okay, so that means I would just not update. Um, and yeah, this one includes angular and linear. But when I'm doing the updates, I do the impulse, I read. If it has linear, then I will move it according to that. And if it has angular, I will update it according to that. But by the apply impulse, I think I'll probably just write the code out myself. That's annoying. I don't think I need its RID anywhere else. Get contact collider. Right, and then solve forces. Yeah, this one I'm only calling solve forces there if I know for a fact it has something. So I can just do get collider ID. It is I want to do a case or a switch statement. Oh, it's static, it has neither. But I'm always reading the velocity anyway. This is just determining if I update it. I feel like the name is bad then. The name isn't right. I'll call it update. In fact, I actually want both of these. Technically, for the player, I don't have to worry about it as long as I have the spring. Wait a second, where do I apply that force? The spring total force. Okay, so it's like applying it at the center of mass. Is what this means. Right? I'm only moving it and I'm not rotating it. Which technically is not what I should do. I should apply it at the midpoint of the spring. On the body. That's where I should be applying it. I'll just do body, linear body, angular. Instead of having the update there. That'll just be a pass, I guess. And I guess it's allowed to go either way, right? Like technically I could pass body state being null and that's fine. But if they're both null, then I have nothing to do, so. Duplication does suck, but just gotta deal with that. This means kinematic, I only apply linear motion, I won't rotate it. The reason for kinematic is, I think generally, kinematic, you're never rotating the body, you're pretty much only using it for something that's just like sliding around. So I just won't even update the angle. Yeah. Then I guess up here I'll just say there's nothing to do. Actually, this is not ground contact velocity. This is ground velocity. I'll just call it ground velocity. Since at least in my case, the body's not rotating, linear velocity is the same everywhere on the body. I think there's already a 0, so I have to write this like that. And then I guess I have to compute this effective mass thing. Which technically I tell the spring how much mass it should be lifting. So I'll just do that. But I mean, actually, the mass... I believe effective mass depends on its velocity. There's something here with this. Okay. Okay. Templated to calculate inverse effective mass. Templated to calculate inverse effective mass. There we go. In inverse mass 1 plus... Oh my gosh. In inverse inertia 1. R1 plus UX axis. In R1 plus U. store float. I guess that is copying the value from there to the other one. That's what it sounds like to me. So if we're not static, in R1 plus U, what is in R1 plus U? In R1 plus U. Is it the angular velocity? That's my thought. It's the angular velocity. Right. It's adding the, I mean, that must be it. We take its inverse mass plus whatever is coming in from its inverse inertia, which I think is what this is, in inverse I1, inverse inertia 1, crossed with this. And then we add that dot with that. And I guess if I had to like guess what this is, it sounds like rotation 1 plus U. I don't know what the plus U is. In R1 plus U. It's a vector 3. Calculate inverse effective mass. Calculate constraint properties. Okay, calculate constraint properties. MR1 plus MU. And then that one's just MR2. What is MU? MU. Calculate R1, R2. Well, that's actually the place it's set. So it gets the offset of their center of masses and then adds the difference in rotations. A 4x4 matrix. Oh. It's not its angular velocity, it's just its rotation. It's just the current rotation. Calculate R1, R2U. There it is. It's just the rotation. It's not angular rotation. I need a break. I'll be back. I'm back. All right. Okay. R1, R2, and U. Body 1, get rotation. Wait, what? Oh. Oh, okay. It does it solves and then it does it again for limits. Okay. So it takes a rotation. I guess that's converting it to a basis. So it takes the rotation as a basis, which is what I have. Wait, what? Rotation must be a... I gotta find out what rotation is. It's probably body interface. Get body, get rotation. What? Well, that's annoying. Because it's definitely just some dumb, like, inline function that's returning M rotation or something. I think that's exactly what this is. But I need to know if it's rotation or if it's angular. A quaternion, good. Okay, that's what I want. World space rotation of the body as a quaternion. Awesome. That's what I wanted to see. It is a rotation. It converts it to a basis, which is what I already have. And then it does calculate R1, R2U, which is just... I guess it's a relative rotation, right? It's the relative rotations. Local space position 1. That's gotta be a... It's a vector 3. Okay. Okay. Can I find a better place that does calculate constraint properties? Wait, what? Calculate constraint properties with stiffness and damping. Calculate suspension force point, wheel R1 plus U, R2. Calculate suspension force point. Force point plus minus center of... These are positions. The force... Okay. So R1, R2 is the relative position, is the position relative to the center of mass. Okay. So why was the other one considering rotations and inertia? Because this is what I want. I want to treat it like it's a suspension. What? I think this is still, okay, it's still relevant, but now that I know what R1 and R2 are, they are relative positions on the body. Still don't know what the plus U is, but it doesn't apply. I want it to behave like it's a suspension. That's what I want it to behave like. So I don't know what the plus U means. But I do know in the other case, it was the difference of center of masses plus the difference in rotations. That was the plus U. Or is a difference in... Wait, what? Okay, no, I need to see what it was now. There's a price slider. It's probably the first ones. Or it's up here, slider. Calculate R1, R2. The difference in center of masses and the difference in rotations. No. No, it is. It's a difference of center of masses and not the difference in rotations. The difference in positions. So I take that local space position of each, multiply it by its rotation, which is just the basis. The difference between their local positions? Why? Why does that matter? Get center of mass position. X1 plus R2 minus X1 minus R1? Also, they're already vectors. Why do they make that a new vector? It's like x2 minus x1 plus r2 minus r1. Okay. Why is it written this way? That vec3 kind of doesn't have a point to be there, I think. Jeez. It's like I get hit with a sleep stick. Like, I swear. Just for like a moment, I just feel incredibly tired. Like I could literally just lay down and fall asleep immediately. I don't understand this. This is bothering me because it's literally taking the relative position plus this value. Which, actually, if I think about it, since this would be R1 minus R1, so it's just... So this input is actually just the difference of center of masses plus the relative position of 2. That's what this is. And I'm just going to assume center of mass has to be world space. There's no other thing it could be, I think. Or maybe not. Maybe somehow it is that. But R1 and R2. Force point minus the body center of mass. It's just so weird. It's such a weird thing. Also, is this correct? Is that supposed to be in rotation 1? Is that right? Why does it feel like that's probably wrong? Everything else is rotation 1 times local space position 1, and then rotation 2 times local space position 2. Is that wrong? That's gotta be wrong, isn't it? Maybe it's not wrong, I don't know. I gotta wake up. Wake up. Wake up. Wake up. Wake up. Okay. You know, I'm just gonna say that's probably wrong, but I'm not gonna touch it. I'm gonna forget about that. I cannot get that distracted. But I just noticed it. Should I mention it? What should I do about this? There's got like, why is there not a comment about it? I feel like I feel like this deserves a comment because it just looks wrong. And that's such an easy typo to make because I've been trying to do this, by the way, where every time I write something where I have an A body and a B body, I give them both completely different names, and then I keep the delimiting portion at the start, so it's really obvious. I could say has linear underscore 1 and has linear underscore 2. Like that's the kind of the equivalent of what Jolt does literally everywhere. The variable is delimited by the last character for some reason, which is awful. I'm gonna say it. That's terrible decision making. Don't do that. Don't delimit two very distinct things by the last letter. Delimit them by like the first thing. Like self-rotation or self-local space and then other local space, right? Like do that. And don't even do local space position, local space normal either, because now you're still doing the same thing again. You're delimiting it what it is at the end. It should be self, rotation, local. Self, normal, local. And I'll also at that point probably just get rid of local because it's kind of redundant at that point too. So it's just self position, self normal, other position, other normal. So the variables look as distinct as possible, because looking at this, I could even understand a typo being like position 2 here. And it would look okay, but it's like a typo in the middle of the word. And then don't name things MR1 plus MU. Don't do that. Don't use a single letter for any variable ever. There's no need. trying to understand this before I continue. I want to make sure I understand why it's like this. Why the vehicle constraint uses just the point relative to the center of mass, which, yeah, force point is a global position. Get world to transform. So this is also a global position. So yeah, R1 is an offset from the center of mass. R2 is an offset from the 2 center of mass. But then, I mean, maybe here too, because local space position is probably relative to the center of mass, if I had to guess. And then it's just rotated. So this would just be the difference in offsets plus the difference in positions. Which I don't know why you would write that. Because then, like I said, because of what mu is, when you're adding it, you're subtracting R1. So technically what you're passing in here is only this part. So the difference in centers of mass plus the relative position, I guess the force point. I don't know, maybe they're just different, which is strange. Why are they different? Get current position. U dot So I think about these as vectors. This first part is a vector pointing from object 1 to object 2. And then I add that offset. So this is basically the So what I end up passing in here is vector pointing here, and then add wherever from body to center of mass. So if you think about it being like end minus the start. Starting with body 1, draw a line to body 2, and then draw to the position of the joint on body 2. That's what this is. So this is basically the point, body 2's connection relative to where body 1 is the first parameter. So basically we're treating the point as R2. The point is R2. We're drawing a line from body 1 to R2 and body 2 to R2. That's what this is. Okay, now I understand. All right. So I still have a single point. In this case, that single point is R2 here. That's like the force point. But I'm accounting for rotations. The vehicle constraint... World transform, I'm taking the point and I'm... Right, okay. So force point is the relative position from the main body to that suspension force point. Vector pointing there, and then that one's vector pointing there. Okay. Okay, makes sense. What was all that for? I need to know what R1 and R2 were. Right. So then we get into axis constraint part, which is what everything uses for springs. Because axis constraint part actually contains the spring. And okay. So in R1, cross world space axis. I don't really need to care what that is, but that's what that is. R2 cross the world space axis. This is the direction the spring goes in. Inverse mass plus, that must be the inverse inertia, inverse I1. I'll just run this again so I can see. Inverse I1, inverse inertia. Perfect. So we take the inertia, multiply 3. I'm assuming that's the transform, right? So I take that inverse inertia. Oh. It's the inertia tensor, right? Yeah. Yeah. Inverse inertia tensor. That's what this is. Yeah. Basis of 3 by 3. Right. So when I say inverse inertia, it's actually the tensor. So the tensor, just transform that. I get this. And then I do mass plus that value dot the axis. And then here I add that. And it's both these combined. Okay. I'm going to write that as its own function. What is the inverse inertia? It is the inverse inertia tensor. Okay. Calculate inverse effective mass, and then I need... Well, I have the direction already. So the direction is... Yeah, it's just direction. Right. Okay. So the effective mass is the point, the effective mass, the inverse mass, plus this force point, wherever that is, with all this stuff done to it. Right? So R1 plus U is a relative point. So I need to know, I guess, where that force point is. In global space. And I think I just apply it to the halfway point. No. For body A, I apply it... for body A, I apply that force at its position, its relative position. For body B, I apply that force at the contact position. I'm going to check the spring. If I tell it a force point, that's where it applies it. Otherwise, it's at the contact point. Okay, so I guess it is just at that position. Okay. So it's going to be the collision point. Okay. And then yeah, I guess I don't really need 2 points here. But I do write this, I will write all this out anyway. Global coordinate system, right. Okay. So do that. There's R1. And I take R1 plus UX axis. Right. If the body is not static, though. If the body's static, I don't count it, which yeah, is exactly what I should do. Why does it like do that? It's really annoying. Oh. I don't have the RIDs. Why can't I get them from here? In fact, why is just the mode just not even here? One sec. I gotta talk a bit less. Okay. I can't do that. I have to just not pass it in if it is static. I hate. Stop writing code like this, please. Nobody ever write this code again. Never, ever, ever. This is terrible. Just hit it. Just hit new line. Hit enter sometimes, eventually. 1, 2, 3, 4, 5. Sixth parameter. One, two, three, four, five. Sixth parameter. The negative contact normal. contact normal. Really? The contact normal. What about here? Calculate constraint properties. One, two, three, four, five. The fifth. Okay, so position constraint part just not a thing, I think. It's just not a thing. No. So, I mean, okay. It's the negative contact. That's kind of different, though, isn't it? It's actually not, because it just passes it in there. Inverse effective mass and world space axis. Oh, you know what? That actually does make sense, because if it's the contact normal, then it's like, you know, the direction that it's pressing into the body, and that's how you get the inverse inertia at that point. Right? Yeah. That makes sense. So body relative cross direction. World space axis. This is supposed to be the contact normal. No, it's not making sense now. I'll just... I need the normal. The collision normal. Normal, okay, collision normal. Perfect. The negative contact normal. Yeah, I guess the question is a normal point. I guess the normal is the normal on this body, which means it points away. So I probably want to do the negative. So that's the negative contact normal. R1 plus U is just the relative position. The force point, which is going to be there relative to this body's. I guess it still just feels weird that this is... The max would be 0 if they're looking at each other, right? If they're like this, it's the contact normal, so it'd be like pushing up here, right? So then I would get essentially that one or one of these two, which is just the axis that the body... It makes sense to me now. It makes sense to me now. I get it. I get it. I know. I see what's happening. So then we take that plus the inverse inertia multiply by. Okay. How are they calculating this? Inverse effective mass is inverse mass 1. R1 plus ux dot the inertia of it. Oh my gosh. I'll be back. I'm back. I just had a thought. What's a dot product? Wait a second. Okay, no, it is a bit different. I was gonna say, is this like the opposite of a... I mean, alright. That's cool. I didn't have that realization that that's what... Just taking the relative position, crossing it with a global axis, and that gives you the local axis of rotation that the point... that pushing on that point causes. It also has the side effect of having like a length attached to it, which I don't know what that really does. But I guess that's like how powerful it is, right? How far away you are. So just plus the relative axis dot that. Yeah, so just make sure when I do calculate inverse effective mass, I only pass things in that are not static. Awesome. Wait, isn't the... Because my direction points up, and this is cosine theta up. It's already correct, so I actually don't do negative normal, I just do normal. Collision normally gives me the normal on the other body. Okay. Calculate inverse effective mass. Is there. Which I'm gonna need that a bunch. And now it also includes rotations. Calculate constraint properties. I just get the inverse effective mass, and then I do calculate spring properties with bias. C. 8. What was it? Stiffness and damping. And bias in C. Bias. Okay, so I actually treat bias as being nothing. I think bias is meant to be like disregard the force applied by this one. So this one's applying some force, so don't apply that force. Or maybe it's like apply that force in reverse. Yeah, okay. I think it's just that I don't include it. It looks like it looks like it's just a force that I'm adding, actually. So the bias looks like it's just literally a force that's added on top of everything else. It's like it's just permanently added to it, right? Yeah, okay, so it's just a bias of 0. Okay, so in bias is just always 0. Then of course there's the in C. Okay. There's nothing, return. Set up everything, then run through here. Okay. Solve velocity constraint, get total lambda, clamp, apply. Which takes the difference between the new one and the previous one, sets the current one, and applies that change. Which effective mass. There's something a spring is recently that we're looking at. It was like a spring scale. One side you had a mass of like 20 newtons, and the other side you had a mass of 20 newtons, and it was like, what does the scale say? The scale would say 20. Then it's also like the total force exerted on it is like 20 plus 20, right? So that's what this is. That's what I'm getting here. How much mass is being applied to the whole system? Am I doing it like wait. Am I doing it like this? Softness times lambda plus bias, which is always 0. But it's not always 0. It's calculate spring properties with stiffness and damping. I mean, I could do frequency and damping. I mean, preferably I actually just set up a frequency and damping, so then I can just totally ignore. I don't have to do this mass thing up here anymore, which is what I would really like to do. But I actually prefer setting up frequencies instead. No, it does have to be a stiffness value. What unit is stiffness in? Because I think I just have a bad setup here. Stiffness is effectively is Newton like kilogram meters per second? I can't look it up because it's gonna just blast my the acceleration of 1 kilogram in meters per second squared. The acceleration of a kilogram. So if I have 100 kilograms, I need to accelerate it 1 meter per second of acceleration. 1 Newton is the force required to accelerate 1 kilogram at 1 meter per second. So to negate gravity, I would need 9.8. Right? To accelerate, or to lift 1 kilogram. Or not lift, but suspend 1 kilogram. I would need 9.8 newtons. So if the mass is 100, I guess I can just multiply the mass into that so then I have the value. And then I can multiply that by 9.8. So now 1 unit of stiffness implies 1 unit of stiffness times mass times offset, which is in meters, times 9.8 would mean 1 meter of displacement will fully offset that. That's what that means. A meter of displacement will match the mass. So if I say I guess I could think of it as like multiplying by 10. Does stiffness damping do anything besides just setting the value? Okay. You know, I'm actually going to follow that one. But now I think I have a better understanding of it. Okay. So if I were to do whatever the offset is, times mass times 9.8, 1 unit of stiffness means 1 meter. 2 units means a half meter. 10 would mean 10 centimeters. 100 would mean 1 centimeter. Right? I think I'll attempt to use this one because I saw how the car worked. The car uses this, right? Vehicle constraints use the axis constraint part, which uses just the spring part, which has this kind of whatever function implementation, which I really like. It's really good. I would like to have that. So I'll try it. So Soul Force's bias is just, you know, whatever change in the offset. Okay. It should be that if I move something and I force an update, right? Because I think I'm using that already somewhere. Well, I'm using I can use force update, but I don't know if it does anything because I don't know if that means anything has moved yet. I mean, I guess I can find out, right? I can find out the link changes. And if it doesn't, then I can probably find some other way to pretend like I've done it. I don't know. Hello, Dory with a lad. I feel like I should save more stuff. Yeah, I'll do this. And my programming exam tomorrow? Oh man. Well, I hope you do well. Okay, so now I have contact point. And that means I remove this. Yep. Okay, so I get that's the relative contact velocity. I need the length, which is actually just from here. So there's the offset. Okay. Relative contact velocity. I think I'm just kind of copying all this stuff in here. So I have length minus the max length plus the height offset plus the bias. Wait, what's bias? Additional offset for the spring. Okay, right. Additional offset. So I think I just copy that. Oh, yes. Cosine theta. I'm not really using this. I'm doing it myself, which is going to be the relative velocities. But it is speed in something. Ground relative contact velocity dot the spring direction. Oh. Is that really how it is? JV is 1 minus 2. The axis, okay. Dot 1 minus 2. Okay, so that's actually the contact normal. Templated velocity constraints. So velocity constraints. In world space axis. So velocity constraint. It's the contact normal. Really. It's kind of crazy. Note that it can only push and not pull. Yeah. The contact normal. And not the direction they travel in. Looks like an abnormal amount of math. No. It's an abnormal amount of template functions, that's for sure. The math is like... There's like actually probably 10 lines of math in this entire file, and it's like 700 lines long. So... I'm actually confused. Why is it the contact normal? I guess I just trust it. I think I can just go ahead and cut that out. So I'll be doing the calculations in here. I guess I'll just write that. I don't understand. I mean, I just have to trust that. I really don't. Okay. So I take the contact normal and their relative velocities on that normal, or in that direction. It is actually a little bit strange because the contact normal. Position constraint part limit. M a world space slider axis. This is different. But I do want it to be like this one, which uses the contact normal. I'm curious. Vehicle constraint parts, third party jolt, physics, vehicle constraint. Line 563. Same thing. Okay. What was this commit I just had? Improve suspension. Right. Yeah. Limit based on contact normal alignment with the wheel suspension axis. Do not reset suspension length. Remember it between calls. Line 230. Thanks for following. Dory the lad. Okay, that I don't really care about. But the other one, this one, is what I thought should happen. This was originally doing target length, max suspension length times the fraction. Target length. Out suspension length. Vehicle collision tester. C.S. So you gotta sleep for my exam? Alright, yeah. Yeah, hope you sleep well. Gosh, this is what this is. Vehicle collision tester. Wait, what's patches? Hang on. They have a patch to change a comment? Really? What's going on? I'm gonna assume those are probably... Yeah, it says upstream commits. These are probably commits on Jolt. But they didn't put them here, they put them as a... I don't know. Okay, there's nothing here. I was looking to see if there might have been something in vehicle, but there's not. Vehicle collision tester. Also, I probably meant to have this open still. Okay. In origin, in out suspension length. That's Ray. Sphere. Cylinder. Same thing. Last parameter is this suspension length. collision tester, collide, W suspension length. Okay. Suspension. Wait, what did I say? Yeah, that one. C is okay. C is like what I want to see. Length minus the max length should be negative or something, and then okay. I just wanted to have C there. It knows exactly what C was. Yeah, okay. Is there inclusion? There's no inclusion for... Then I limit the length by that, and that helped? I don't know, I'm confused. I think it is because the force just seems wrong to me. It seems like it should be taking it relative to the axis and not the collision normal. Let me try to think about it for a second. I think I'll just try both. But I know that what I did here was good. I know that this was good. But what this does is it takes contact normals alignment with the wheel's suspension axis. Essentially changes what the compression is. No, wait a second. Wait, huh? Wait, why did wait, why did that? Target length is max suspension length. I do max suspension length times 1 minus that plus... What the hell is this math? Because essentially what I'm thinking of is like, if you like literally have your suspension and you push it against like a flat thing. So you have your suspension here, it pushes up and down this way, and you push it sideways like this. It should just do nothing, right? It should hit that and just do nothing. What happens is at this instant, this will compress some amount and then have like a collision normal like this, right? That's what would happen. With like a cylinder or a sphere, which is what I'm using. So that would happen. I think what this was actually for is because it's a cylinder and it's not a sphere, if you hit the wheel sideways, the collision normal will be this direction and the wheel will come up. But it will apply like no force to that. That's what this is doing. I don't care about that. All right. So the relative contact velocity, oh geez. I'm doing this forever. 1 minus 2. It's 1 minus 2. Okay. And then I do world space axis, which is the contact normal, dot that value. Okay. Right. Calculate Jacobian multiplied by angular velocity. That's already included because this includes the angular velocities. Then I would do effective mass times JV minus this bias thing. What was it? Mass. I would be calculating the effective mass. And then here I have to know right, I have the modes here. Okay, so then I can say if one of these is static, what was the point of the static? That's included. Right, for effective mass, if one of them is static, I don't pass it. And in fact, I'll say true here and then just do false. It'll be a bit easier. And I'll do the same thing. I'll do body and other instead of ground. This is not really necessarily ground. Whatever, let's just leave that. Um, it's not cost anymore. Position. Oh, there it is. Combine restitution. I have to get that. Should just be adding them together. How does this work? I add them together and climb it between 0 and 1. So if it has a state, I will add it. But then I need the RIDs, which I don't have. So that's annoying. Actually, I don't need that there. Never mind. I don't use that there. This is for like just a bounciness to the collision, which will take the final relative contact velocity and add what? No, I need this. I need to know this. Okay. I have to have restitution. I also need restitution. Which could just be... normal dot this minus that. Right? Collision force normal times normal, which would be like 1 minus 1. Now I'm really confused. I add them together. Alright, but I have to pass it. I do have to pass it. Wait. Right? Because every time I do the collision, I am also counting as just like a rigid impact as well. So it's like they're going to bounce off each other, but then the spring is going to compress a little bit. And the spring is going to compress a little bit, and then they're going to bounce off each other a little bit. Like that's what's happening every step. Right? So... But in that case, relative contact velocity was the other way around. That's right. I'll just say this could be 0. In fact, I actually will flip it around. Because it feels more like you're normally just gonna provide a bias and not always a restitution. But then if you do, it's there. So the normal... Is that right? Okay, let me look at ground normal. Update ground. Ground or normal is a collision normal. Okay, so it's actually pointing... Right, okay. So it's actually pointing off the ground already. That is true. Which is like the direction that the spring force applies in as well, sort of. So when I cross with normal, This is still like weird that that works that way. I guess you would think you would have to make this negative, but you actually don't. Because it pointing the wrong way is already like gonna rotate it properly. Then I don't know. I don't know if that makes sense. I just need to say that out loud. Because you would normally think you need like some kind of negative in here because the normal is relatively different between the two. Yeah, okay. Let's close like once. I'm gonna double check that one. Oh, it was not here. It was here. Really? I had some changes here that I didn't even commit yet. Dang. So I can't see what this used to be. Really? I'm shocked. Okay. That's crazy. I thought I didn't do that yet. So I don't know what that code used to look like. I think I converted it correctly when I copied it. I would have been careful when I did that. Change the values that I know needed to be changed immediately. But then I don't know if I did all of it or if I messed up. Dang. Restitution times normal dot relative contact velocity, which relative contact velocity is, it used to be 2 minus 1 and now it's 1 minus 2, which means these have to be inverted now again. And in fact, I kind of, no, that's not how that works. It has to be negative on the inside if it's going to work. Relative contact velocity. Two minus 1. So bounce restitution could be 1 times some value but limiting it to 0. You know what? I'm going to assume that's probably wrong, and I'm going to revisit that. So for now, I'm going to drop this. So it doesn't have any effect now. Yeah. Back to this. The angular velocity is already included. It is one minus two every time. 1 minus 2. World space axis. In the other case, it was the negative world space axis is the negative contact normal. Which I'm just going to figure out if that's even correct later. Because normal kind of already is the negative contact normal. Or at least it should be. That's what I've been using it as. Normal is the get collision normal, which I have to get it here. In fact, I'll just do normal and then contact point. Seems good to me. I gotta clear this. It's getting annoying. Okay. So JV is the normal dot the relative contact velocity, which is 1 minus 2. And lambda is going to be effective mass times the effective mass, not the inverse effective mass. Which you need to calculate that. Which is up here with the mass, other mass. I want to provide other mass. And it kind of doesn't really matter that I do it like this. But I'll write it like that anyway. And what if there is no mass between two? What does it think about that? It's probably not allowed to have that. It just doesn't, yeah, it just doesn't do anything if it's 0. If the effective mass is nothing, what do I do? I can apply force. Right. This is also per step, which is more just like I deactivate it on this step. What does deactivate do? It just sets total lambda to 0. So I guess it's like I don't add anything, right? So I just will continue, I think. And I guess I do a check here if not body mass and not. If neither one of these could contribute mass, then I'm done. Right. But at this point, I know for a fact that at least one of these two is true. So then here I can just write else. Okay. Yeah, I guess it is possible that somehow the collision just happens to be doing nothing. Right? So we would just ignore it. Maybe I'll just check if both of these have 0 inverse mass as well. I'll write that. If it's greater than 0, set it to true. And then here when it's static, we definitely set it to false. So now I can be sure that at least one of them has a positive mass. So no matter what rotation it's at, it's going to be there. So this should never be 0. This should always be a positive value. Axis dot These values are always positive, I think. So if I translate any axis, yeah, because these are always positive, I'm basically dotting the axis with itself, with some scaled value of itself. So it should... It should always match. Yeah, there's no way inverse effective mass could come out as like something negative. I don't know. That just shouldn't happen. Effective mass is 1 over effective mass. Okay. Okay, so we're doing calculate spring project with bias. Bias is always going to be coming in as 0. So I'll be computing the softness and bias value. Changes to offset instead of bias. It's called offset. Call it extra offset. Here we go. Now we can call this one bias. The in delta time, which I'm sure is just the real delta time. So that would mean step times substep. So there's delta. Whoops. Buttons. Damping plus stiffness. No bias. Delta. Here. Okay. And then new effective mass. Out effective mass. So I provide an inverse effective mass. And then I get a new one. M effective mass. So I give it an inverse effective mass. Okay. Sure. And we're calling get bias, which is softness times total lambda, which is something, plus that bias. Spring part times, or effective mass, which templated solve velocity, which one is this? I do set a velocity constraint, and then I do solve velocity constraint. So solve is using that effective mass that I've calculated out from there. Okay. So it's that effective mass times JV minus spring part get bias of some running total lambda, which is this. Minus spring part get bias with total lambda. Softness times lambda plus bias. Total lambda. Total lambda, return it. Total lambda. I apply the delta, and then I update the total. So the delta in this case actually is the lambda, and then total would just be total plus that value that I calculated. And then I apply that step, which would just be doing, I think it's just called apply. Yeah, it would just be apply impulse, but I need to do it in a way that apply impulse updates the velocity and the rotation. So I guess that's, for now, that's what I'm going to write. I think I get bias now. I think impulse is meant to be this bounce collision, right? It's meant to be that. That's meant to be the bias. Because then spring part just uses, you give it the bias and it just adds it there. No, never mind. No. You know what I think I do? I think when the spring reaches, I could say when the spring reaches its maximum up, but that's not really how it goes. It will reach the maximum up, at which point the rigid body itself will hit whatever I'm falling into. At that point, I don't have to worry about that one because that collision is going to be handled. So I don't have to worry about the spring. I don't need to worry about bounce at all. Really. I mean, maybe I should, because then, like, the surface could be bouncy, right? So if I were to push off a bouncy surface, I get... I mean, what does that even mean? No, it would definitely still be, like, that rigid push into something, right? I'm thinking about, like, an elastic surface that you jump into, it'll absorb your energy and then rebound you, like a trampoline. That's what I was thinking. Hey, Dylan, I bet you chug soy milk? No. I drink regular milk. Not the 7-hour mark, really. When did I... Oh, wait. Hold on. Do I need to account for that? Well, it's more like if it's absorbent. Then that means it'd be -0 anyway. I don't know. I don't know. I think I should just probably ignore it. Yeah. If I want to do it, I'm gonna look into it later. I'm just gonna totally remove it. Effective mass is already there. Argument 2 should be, but is bool. Oh. Yeah, total lambda is 0, and I'm just accumulating some change, which will incorporate this back into itself. Okay. Total lambda plus delta lambda. It's the axis constraint part. Solve. templated solve, calculate a total lambda, clamp it, apply the total lambda. I get the delta, which is just the same thing as this, because it would be this result minus this value. So it's just delta lambda. And then I apply that velocity step of delta lambda on this contact normal. Axis constraint part. I still don't understand the axis constraint part. In world space axis, I don't know, it's still strange. It's still strange. Oh well. I'll just go with it. Inverse inertia. Inverse R1. This is the inertia tensor times whatever I'm doing with the here. Okay, no, I get it. So I need it to actually save something. So that is the inverse inertia tensor times the axis. Inverse inertia times axis. Now it matters which one I give. Are you a cat now? Am I right about that? These names are terrible. The tensor times the axis, which is the cross, times the axis, which is the cross, which is relative cross the contact normal. Okay. Alright. Now I have that, so when I go to add the step, I have Is that correct? Yes. Lambda times that value. R2 x-axis. R2 x-axis. Why is it inverse 2 R2 x? Like, obviously it would be whatever. Body 2 rotation axis. Is it like that? Was that too simple for you? UX axis. R2 x axis. Cross axis? Cross axis? You see the thing about the what? No, I don't know about that. Okay. The delta lambda times its inverse mass times the collision normal. Also, this is subtract. So sure. Delta lambda times in lambda apply velocity step. It's applying it as a full step, it's not applying it as... Which, no, it actually is applying it as a smaller... Apply step. I need to know specifically what this is doing. Is the lambda already sublinear velocity step? It's changing it by that value. Okay. It's changing it by this value. So that means, since it's changing it by that value, lambda is already deltaed, is what I'm getting from that. Get total lambda. So velocity constraint, total lambda. So velocity constraint. Calculate constraint properties in delta time. That's the only place delta time is used. Okay. So then I'm just literally using delta lambda. I'm literally just using delta lambda. Alright, delta lambda times the normal. Times the inverse mass. Lambda times inverse mass. times the axis. Now, where's their relative? That comes from other axis. Right, okay. So I update those values, and then I because delta is step times substep. Right, it's the iteration. I'm keeping track of total lambda over time. I mean, I guess technically I'm supposed to just actually keep the total lambda going. When they do setup, the setup reset it. Calculate spring properties here. This doesn't even do that. All right. I guess I'm actually just tracking it forever. I guess the idea is that if it's not like perfect in one iteration loop, then because we remembered our work, remember the work that we calculated, we'll start off with a better next step, I guess. I definitely know, like, once I do run it, it's gonna like explode or something's gonna happen, or I'm gonna like be jammed into the ground and then, I don't know, blast off to infinity. It's gonna be something crazy. And then I only want to move it. Right? I think I only want to move it by... I mean, really, it's like, it's kind of fine if I don't. Like, at this point, it's actually kind of fine. I don't really have to move things. I don't actually have to move things. and this will solve it correctly. Because if I don't move them, then I don't actually have to use these. Because this is directly affecting it. I don't know. I definitely think this is wrong. This should probably be flipped. Right? Unless somehow... And in fact, where is offset? Offset is here in the bias. Okay. So I just want to check that I have offset correct. In C would be calculate constraint properties. C is the current suspension length minus a max length minus some offset. Okay. The current length minus a max length minus some offsets. Okay, that's correct. Good. Contact velocity is 1 minus 2. So calculate constraint properties. Which is in inverse effective mass uses this. No. Where is that used? Where's the velocity used? It's in JV, 1 minus 2. Okay. In world space axis. Solve velocity constraint. Contact normal. It's just so weird. It's just so weird. And I can do the same thing. I can do offset multiplied by... I'll do it. Actually, what was this like crazy code? The target length is out suspension length is max length times the fraction. That's right. And then target length becomes max suspension length times 1 minus a dot. What is this? What is this? What is this? This looks so strange. Because I would think it's just this one. It's just that one. Why do I add this bit here? What is that at the front? I'm adding target length times I believe suspension direction points up. The out contact normal I don't know which direction it points there. This is so strange. I'm gonna leave that. I'm gonna leave that. Because this is not a cylinder, so I'm not gonna have a sudden, like, you know, 90-degree impact. I'm gonna have like a smooth impact, right? It's gonna do this. It's not gonna be like this one straight to here. It can be like, right. I think I could probably run it immediately and see. It doesn't like that I have restitution not used. Yeah, I'll just underscore it for now. Then I guess I'll just comment these out, so I'm not worrying about it. Okay. I guess I'll find out. Yep, that's what I thought. Normal on null. Oh. Okay, so something interesting is happening. Ooh, a bunch of errors. Look at that be. No collider RID found. Okay. We have an extra error though. Hit point is never. It just can we just ignore that one? Very silly. Oh, let's just see what happens when I land normally. Okay, I'll be back in a minute. I think it is just because stiffness is too low, but also it's possible I have problems where that acceleration is applying the wrong way, so I'll actually have to step through it and see what happens. I'll be back. I'm back. Let's change this. All right. Close that. Close docs. So yeah, I'm just gonna run this because the first thing that happens is the collision with the ball. Which it seems like right now it just does nothing. If it does apply any force, it's like no force at all. Which I'm assuming is just because the stiffness and the damping are kind of crazy values. Stiffness should be like a large value, and then damping should be... I think damping is supposed to be a value between like 2 and 1, or 0 and 1. So let me see. Spring part might say it. That damping. I think it says it up here. Even when you set the damping ratio to 0, it's like a stiffness and damping. Spring damping coefficient. K and C. C, K. I mean, this has got to be like rage bait at this point. We've named 2 parameters C. In C and then C. Which one is C? Because this one takes in C. C, stiffness, damping. C, stiffness, damping. Damping is that thing. Does vehicle constraint have... I think it's on wheel. Wheel settings. Spring. It comes in with frequency, which is better to work with on vehicles, I guess. Okay. Alright, well, I guess I don't know. I'll find out. Stiffness is 2.5, damping is 2.2. So I'll see what they say. I'm just going to jump right down here. So I've got everything true. Technically, this should be imparting rotation to me, but it didn't. Well, I mean, it didn't probably because it actually just can't, because I think the controller is axis locked, so it actually can't. So that makes sense. Anyway, delta is 1/5 of 100th. So yeah, it's pretty good. Body velocity. We should get a body velocity, which my velocity is 7.06, which is what I expected, and then other velocity should be 1. Yeah. Okay. So then effective mass. I'll just step over that. It should be like 101, basically. 1001. 1001? 0.01? What? Okay, well I think that's instantly wrong. Because this is supposed to be inverse mass, which means it's like a very tiny value. It should be like 1 or less. It should be less than 1. Because, yeah. Continue. Okay. A force point, which is 4 and 3. Is that correct? I think. Yeah, ball 2 of the millennial, so this is 4 and 3. Okay, good. 4 and 3. So relative. That's wrong. All right. Skip, skip, relative. Really? Oh yeah, relative to the center of mass. Right. Okay. Relative to the center of mass, that makes sense. Okay. So then I have axis 0, which is exactly what I wanted to see because it's pushing directly into it, right? So an inverse effective mass ends up at 0.01. Perfect. Now this one, relative axis 0, (1.01). Perfect. Now what gets me is that this would do 1 over that value. Which doesn't seem right. Because when I inverse this, I'll get I mean like 1.01 or something like that. We could run 7 hours as an epic run. When I started early. Yeah. I just was ready to go early, so I did. Gonna lurk mode to say goodnight. Alright, yeah. Sleep well. Thanks for hanging out. Or lurking. Yeah, typoing the same way twice. That just seems not correct. I don't know why. I'm trying to think of why that's not correct. Is that really how they have it written? It just seems strange. But you know what? Maybe it's just correct. Maybe that's just how it is meant to be. Gonna have to compute softness to get the effective mass. You just compute at the same time. Which I don't even know why these are named these values, because these just seem strange. Softness is delta times damping plus delta times stiffness. Bias, the offset, so it's just this very slight change in value. But wait, softness is like 200. Oh, I guess because delta is also a small number, so then it corrects for that being a large number. Okay. So then effective mass becomes 1 something. It becomes 0.004, actually. Okay. I mean, I guess I could actually look at this and see how this calculates with some frequency. Two times pi times frequency. Okay, I guess I'll just do like mass equals 100. I think they said like 1.1 or like 1.2 is like good for cars, so I'll just go with that. And then damping is between 0 and 1. I'll say 0.8. This is then 2 times pi times frequency. Okay. This is stiffness. This will be out effective mass. This just seems wrong. Okay, I'm like I feel very convinced that the inverse effective mass is wrong. I just feel super convinced by that, because, or is it as if like the masses were acting against each other? I guess so, right? Because if it was 200 mass things, it would look like this. So it'd be 50. I guess it is supposed to be like a ratio between the two. Because if it was like a 100 mass thing pushing a 1 mass thing, the effective mass would be slightly less than the 1 mass thing. Which is because that thing is getting some amount of force and the other thing is getting that also like proportionate amount of force. So it'd be like or this times that, right? So the big object would feel this much force, and the small object would feel this much force. Is like what the effect of it is, right? And then I guess technically adding these together sums to 1, right? But if they are both 100 pounds or 100 kilograms, one mass would experience 50 and the other mass would experience 50. Okay. I understand it. Right, but I was still going through here to look at what, because I was like, oh no, this is gotta be, okay. I'm sure it's right now. So inverse effective mass, so I'll say, I'll actually say mass is, that, right? I'll just say it's actually 100. Okay. So then I have, wait a second. Calculate spring properties with frequency and damping. Yeah, okay. C stiffness down. Okay, good. Stiffness is the 100 times square of omega. Okay, so that's like a very large stiffness, right? And damping. 2 times mass times damping times that. Okay. Okay. So both of these values should be like large relative to the mass, right? I guess, yeah, what if I just start with saying like 5,700, 1,200? What did I say? 5,000. I'll say 5,685. I'll just make it really close. 1,206. Okay. Skip. Take it off. Okay. And this is supposed to be inversed first. But this uses the inverse effective mass? Right, I think they're actually just kind of weird. It takes in the inverse effective mass and then it provides an output effective mass. Oh, this was used to calculate these. This is supposed to be the inverse. Offset, so we are slightly compressed. We're compressed by 3 centimeters. Softness, I'm going to expect just a ridiculously large value. Or not. Because stiffness is a very large value. Right. Some bias, sure. I update effective mass. Right. Relative contact velocity. Minus -7. This is +1, so it should be like -6. Or, I mean, not, because it's minus that one, so it'd be higher. JV, I don't know what these values should be, honestly. Oh, well, I guess it's supposed to be just the pure speed in that direction. And then delta lambda, hopefully is some large value. Or at least for the other one, it will be a large value. So this is effective mass times JV minus softness times total 0. So then that's just 0. Effective mass times JV. So then it's just like this. I sum up the total lambda. Okay. Okay, so what this means is that immediately it's not a 2000 meter per second acceleration. It's 5. It's -5, which means I should be pushing up. So what I want to see is my linear velocity go closer to 0. I want to see this be like -6, probably. Maybe not even -6. It probably won't be -6. It'll be very, very small. Yeah, but it did get closer to 0. This shouldn't apply any angular rotation, and I think this body is locked. I'm going to verify that I have axis lock. I have angular lock. So even though I apply the velocities, it's not going to change anything. But this would be 0 anyway, because body axis is 0. Right. Now the other one should accelerate quite a bit. 1.097. Yeah, I'm thinking this one's going to start going down immediately, right? But then the relative velocities between the two are going to change, and it's going to be another small iteration, so it should improve it. 1.097. Okay, so 1.097 to -4647. For 647. And this is an acceleration over that much time. Okay, so it's still a 2,800 meter per second acceleration. But at least that's comparable to, that is comparable to what I had before. That's not like some order of magnitude different. Before I was doing like 1,900, now it's 2,800. So it's not, it's in the same ballpark. Okay. Right, so now I expect to see these values have changed a little bit. Right, okay. So now they have this relative velocity, which will mean my velocity will kind of like barely increase, and then the other velocity is gonna probably come closer to zero. Is what I think will happen. Total lambda is that. The dog may bark. He did not. Awesome. Effective mass should be the same thing again, 1.01. Yep. This is like an interesting thing. I didn't realize that this was what it was. I think I tried this before and I just kind of added them together. Or that is what I was doing, and I was adding them together. But now I see what it's supposed to be, which is an even distribution of the force to each one. Using their masses, adding them together, adding the inverses together, and then inverting that. Very cool. The offset's going to stay the same every time. I'd like to test to see if I can recast it, move them, and then recast it and see if that even change anything. But it will. Anyway, the softness and bias should stay the same. So bias is 0.16 right now, so it should stay 0.16. Right? Effective mass is going to be the same thing, like 0.7 something. Right? Relative contact velocity has changed. It is now negative 2.359. JB is now going to be a positive value, or I guess it's a negative value. So let me check which way normal is actually. Okay, that's what I wanted it to be, right? Though I think in the spring case, it's actually using the negative contact normal. But I don't know. Okay, so now let's see what delta lambda is. It was negative 5744. It should now be, I think, probably a positive value. Negative 1927. Okay. You are AI generated. Nope. Okay, well, this one is, it's going to continue happening. This one's going to decelerate. It's going to get closer to zero, and the other one's going to accelerate down again. Though it is still with a smaller value now. So maybe it'll be a little bit better. You can't be spending multiple days doing that. I am, though. And I want to see this. So yeah, I slow down again. This one is still accelerating down. I feel like I don't know. It seems wrong. It seems wrong. I think what I have to do is I have to move it and recast the shape. Because what should happen is... It's like, it's such a small step, but now it's... Because it's basically like applying the same thing over and over again to these springs. Also, extra offset is supposed to be some value. Oh no, should it? I guess what I'm thinking of is that it should be sort of like an offset spring where if it I mean, I guess not. Yeah, never mind. All right, well, let's see if they start like reversing direction or something. As total lambda just keeps climbing. Well, I mean, actually, hang on. Maybe it's not so wrong. As long as the other Y velocity doesn't go much higher than mine is, then it's fine, right? Because think of, I mean, it's a 100 kilogram thing falling on a 1 kilogram thing, right? Like, this one's gonna hit and they're just gonna go like this, right? Like, this is what you would see happen. And maybe this would bounce off at a slow speed. So maybe it pick up a little bit more speed, but not much more. As long as I don't launch the thing, right? As long as this doesn't end up with a velocity higher, like an order of magnitude higher than mine, which it doesn't look like it's going to be. But the softness bias, this is all basically staying the same. Though technically these could be causing rotations, but the normal is always the same, and I'm not even physically rotating it, so whatever. Same values. Same values. So the relative velocity is like nearly 0. That's very small. Okay. Six nine eight six 698. Six five seven three 722. That's fine. All right. But now here's where the position updates would be good, because at this point it should start On the first step, there's still like a positive going into me. So it should have been like compressing the spring still. But now in this step, it's moving faster than me, which means the spring should be decompressing and detaching and probably stopping application in a couple steps. Like it might do fewer iterations if it's no longer colliding. But now the relative velocity has changed. So now there's this, which means delta lambda might change. JV is at okay, it's still a negative value. Seven 7.4. Okay, so yeah, it's definitely slowing it down, right? Or basically it's just bouncing off. Is what's happening here. I've slowed down slightly, very, very slightly. And this is now rebounding. And it might reverse. It might pull them back a little bit. Okay, no, it stopped right there. So I've slowed down and this has accelerated quite dramatically. So I am going to do a step. Okay. We've iterated. These are our velocities now. Apparently there's a collision. I'll just go here. Right. What is length? Okay, so it's still compressed. Somehow. I'm actually curious. Where is it right now? Okay, so it's still hovering slightly over the ground. So what is total lambda? Negative 8,606. Actually, what happens when yeah, what happens when I bounce off of something. What is that? What happens to that? I mean, I guess it just becomes, I mean, it should still be getting calculated. It should still be calculating it. As long as bodies are involved. Or as long as it should still be going. Which it does, actually. It goes to solve ground force, which... Okay, that's a good question. What happens when there's no collision? Contact body. Oh, it calls deactivate, which will go to suspension part is actually axis constraint part, which deactivate sets it to 0. Okay, that's probably an issue. Let me just put it here. What is it back? Where's my mouse? Okay, it's just being weird. I don't think I can do that. I think that breaks it if I do that. Why is this running twice? I think it gets that step and then it tries to pause. I think that's what's happening. Because when I click continue and it does another step anyway, it should be like freezing in that point, but it's not. What is the length at right now? it's building up some crazy... I mean, it is hitting a static object, which means what happens is it will go down and push back up into me. But yeah, let me put a break up here so I can see before and after. Because I want to see it. Yeah, so it rebounds up at this velocity, right? I'm still pushing down. Then I'm pushing less down and... it's concerning, this velocity. It is concerning. Concerns me a lot. Okay, now I'm pushing up a lot. And this is pushing down, not so much. But the length is quite compressed. And I'll show this. There's the collision triangle here. There's a contact point happening. So it's actually hitting the rigid body now. Okay, so I'm like bouncing off of the thing. Wow, that's just crazy. It's concerning. Up a little bit, I guess. Alright, 78 meters per second up. Okay, now I am flying up at a very high rate of speed. And this is going down at 500 meters per second. Crazy. 22 meters per second. Negative 23. I am going up at 60 meters per second. Negative 500. Huh. What's total lambda at? Oh. I mean, I have this velocity now, and that's just bad. I have this velocity now, that's bad. Yeah, I think I need to do like actual position movements and do like cast shape kind of thing. But, I mean, it's not even that. It would be better if this was really... It would just be better if this spring was actually a thing that I could set up. It would be better like that. But I don't want to go in there and code it. But this is bad, right? This object is still flying up at me at this incredible velocity, which is pushing me up even more. And actually negative 500 meters per second is the limit, by the way. I didn't even realize that. That's actually the limit. So the project has a limitation on maximum velocities. Is it here? 500, yeah. So it's actually capping out at the velocity. So it basically wants to shoot this thing down at like with ridiculously insane force. Which if I were physically moving the spring and redoing a cast, and that actually meant something in the world when I did that, then that would be good. But it's probably not. I'm shooting off into space now. Am I still going up? No, I'm falling down. Okay. But I'm assuming this is also probably gonna send me flying up again anyway. Oh, I'm looking at the wrong one. Oh, well, I know that I'm falling because my body is leading my camera now. "60 meters per second, jumping on a ball." And it can't even push me off a static floor. What? What? Oh, this isn't even running. Why? I'm not on the floor? If I am on the floor, check if I'm infinite. Do that. If I am not on the floor and this is finite, I am on the floor. This becomes true. What? I'm not on the floor here. Okay. Got a ground normal. Mode is 0. Static. Oh. Hmm. Right. Is there any way I can get the RID from like that value or something? It's just stupid. Why can't I get the mode from this, and why can't I get the RID from this? Like, I can't get that one of those things. Okay, Springcast has to get... I guess has to be given the body RID. And then I'm actually just gonna take that out now. Well, no, I won't. I'll leave that there. Is that here that Spring gets this? Okay. What? Okay, so it's still just like pretending that I can't do anything somehow? What? Okay. Is on floor true. Right. It's still, I didn't actually change it. Mode is 2. Rigid. Cool. I mean, technically, since I access locked everything in Angular, it should have said rigid linear, but whatever. Mode 0. Yep. Double check everything's still happening correctly. Technically, it's still possible for it to have a velocity, even though it doesn't move. I mean, I guess if it doesn't have mass, then I can't rotate it at all, right? I'm gonna say this. Instead of saying mass, I'm gonna say static. Um, I'll do this. Hey, Gilia. 9 hours today. So far, yeah. I mean, I should be stopping soon. Okay. Static sounds better to me. And then I forgot the rest of that change. He's running off one prompt for months now. I almost spilled water myself. It was very close. Oh man, this dog. Shock him? No. Okay. He's off by about an hour on when it's time to eat. Which may also have something to do with me just getting up later for a long time, and now I'm not getting up later. Because it's like 11 o'clock, he wants to eat. 5 o'clock, he wants to eat. He probably has to go out, so I'll be right back. I'm back. Buy a new human. I'm a little useless at doing this stuff, that's for sure. I have been. Right, what do we got? Two centimeters. I mean, those should give me the exact same values almost because it was really close. Well, softness is always the same value, and then bias incorporates the offset. And then JV incorporates whatever. The speed, the relative velocity. That is a huge value. But it is relative to my mass, so. $824 is now $804. Okay. Iterate a few times. It is now 7117. Let this keep going. Oh. It's not pushing up. What? Do I just have like crazy spring values? Did I do it wrong?
How you doing?
Oh, thanks for the raid, Steinbach. Jay Steinbach. Hello. How are you doing? Well, how about you? I am fine. My springs are accelerating too much. You can't see it, but I'm about to fly off at like incredible speed. And a few more. Yep, there I go. Okay. Making a Flash game. Me? No. I don't think there was a mistake here. Unless I am somehow still applying spring. Nope. Lovely color scheme. It is solar something. Solarized. Dark. Okay. I reduce the spring values to I'll just drop them by that. Well, no. Okay. Really? Really? It seems like nothing is changing. It just seems like nothing is changing. Why is nothing changing? I'm not believing it. I don't believe it. I don't believe that this is 100th of what it was, and I am shooting off at like the exact same rate. Like exactly the same, like nothing has changed. Are we real now? Have the values decided to... Okay. Interesting. Okay. Okay. So it is partially because I'm doing iterations and I'm not... All right. Let's just do this. See if this makes it better. A little bit better, but I'm... Okay. And I... Okay. Okay. Is on floor is false. This is from the crawler character. This is from me. Is on floor is true. Why would that be the case? Why would that be the case? It's colliding. This returned a true. Okay. So it seems like it's getting the most buildup when we're pushing apart already. That seems like what's happening. That's really annoying. Okay. I can just hover it? Yeah, okay. Okay. Nothing crazy still. This is compressed. Okay, well, I mean, it should be compressed really far. It seems like there's a bug when it's returning. It seems like it's just not. It's doing something wrong. Huh? My linear velocity is exactly... Okay, well, it's because I bottomed out, right? Okay, that's why. Okay. -2. This is we're applying a small amount. Yeah, very small amount. -5. Zero minus negative that, which means this is going to be a positive value. Bias is a negative value. Right, okay, bias is always going to be negative then. I'm wondering. Because I provide offset. Am I supposed to provide the change in length? Target length. No, I'm just passing it. It just passes straight in. Wait, what is that? Stiffness divided by the cosine angle? Okay, now all right, that actually makes, that's where it comes from. Actually, that's increasing it. Yeah. Because we divide by it. Never mind. We're pushing up slightly still. This is still not enough to overcome gravity. I think gravity is like 7.3 or something. Oh no, actually, because now it's 100th, it's 9. What? It's 0.98 now. So this won't do anything until it becomes 0.98. I guess it probably does have the effect of slowly increasing total lambda. Which means... How is that 0? Oh, because we're not moving. Okay, right, so now I've got... Yeah, this doesn't make sense. Because technically it should not be strong enough to even push off the ground in the first place. Which is... Man, I guess I'm just suspicious about this total lambda thing. How does it actually never reset? Why does it build up? It's like the spring gets stronger as you compress it, which is not, I don't think it's correct. I mean, I guess technically what would happen here is that this would be updating the position of it, which means the spring would be extending, and it would actually move the body up a bit. But also, it's already moving the body up slightly. But now this has actually overcome gravity entirely, so this will end up above the ground. What do I have wrong? Plus bias. Plus bias. Plus bias. Okay. We'll bring the spring back to what I had it at. 5685. One 206. Huh? That can't lit. No. Is this now where I have to use some number of iterations? Otherwise, it won't do anything, ever. Let me double check the math was right, too. This one is actually 0. So it's delta times stiffness times softness times offset. Stamping plus delta times stiffness. Okay. 1 over inverse mass plus softness. This is the inverse mass right now. but it becomes the effective mass. Let me double check that this is also what it's supposed to be. I'm not using inverse mass when I should be using, or I'm not using effective mass when I should be using inverse mass or something like that. Effective mass. That's right. Okay. Now I step through it. So what is DSS is null? Space state is inaccessible right now. DSS. What? Shapecast 3D 394 DSS is null. Do I need to worry about that? Probably not. Well, now I need to see what these end up being. Softness and bias are still the same. Effective mass. I guess that's right, because that's like 0.01 plus 0.4. So it's like 0.5 nearly. So this is, or it's less than 0.5, so it's a little bit more than 2. Okay. Bias hasn't even been incorporated yet, so this is just, it's just effective mass. Okay. Plus bias. Negative 19.3. Okay. Go from 824 to probably not much higher than that, or much lower than that. Yeah, not much. Okay. Let's just jump down here. Delta lambda is 0. Oh, it's a very, very small value. Okay, so I think this is because a position update hasn't happened, but this is still some kind of value. It wasn't exactly 0. Because my velocity did change. Okay. So now it doesn't want to apply anything. Okay. Right, okay, this seems better now. Though... Yeah, okay. All right, so I'm guessing pretty much nothing is going to happen at this point. It's not really going to get... It's not going to build up. It is approaching like a specific linear velocity it wants to have, right? Okay. Okay. Yeah, all right, this is way better. Where's the length? What? Oh, I have A. Okay. Okay. Pretty much did nothing. That's fine. Right, okay. Yeah. It was suspicious that the spring was somehow getting stronger, even though it wasn't compressing anymore. And now this makes sense. The lambda is essentially a tracker of like how much force are we applying each frame. And then I calculate how much more I might want to apply because I've changed something. Okay. But the spring is really strong though. The spring is really strong. But I don't know what's... Yeah, I kind of don't know how that's not... Did I do it wrong? I mean, the idea is that this is how many newtons it applies per meter, which means if I go half a meter, it's 2,000 newtons. If it's a quarter of a meter, it's 1,000 newtons, right? Something like that. Which means 25 centimeters is enough to keep me off the ground. So do I still have a mistake? Because I thought did I try that? Did I just run with it? And see? It's accelerated me into the ground? Alright. Gonna have to wrap it up, I think. I don't know, let me take out the breakpoints and see. No, this is just like... The spring doesn't do anything. Let me see what the total lambda is. .8. How is it positive? It's pulling me into the ground right now, is what's happening. All right, yeah. So there's a problem somewhere. It might just be that the normal is wrong, which would mean I would be flipping these signs around. That's probably what it is. I'll see what happens when I just flip the signs around. Really quick. Get rid of that. Okay. So I flip the signs and nothing happens. It's the same value. Well, yeah, it should be the same value. Zero. Is this supposed to apply total lambda or delta lambda? Delta. It's like I don't know, it's like it's given up. Because what it should be doing is it should be continuously applying that amount. But it's not. Total lambda plus lambda minus total lambda is what this is. This output goes into this input. I calculate it, which is this result. JV minus get bias. Softness times total plus bias. When you subtract the negative, you end up with a positive. .4 times 0.3. All right, I can't figure it out right now. I gotta call for today. I'll probably look at it actually off stream, honestly, and then fix it, but yeah. All right. Well, that's it for today. Thanks for watching. I'll be back tomorrow. Goodbye.